This is a problem that is a more realistic kind of a stoichiometric problem. As you know, we don't measure moles in the lab. We measure things like masses and volumes. And so this problem involves calculations with units that we might actually use in lab. It asks, what is the mass, so mass is something we measure in grams, of sulfur dioxide gas that's produced when 135 liters, again that's something we might measure, of oxygen gas react completely with dihydrogen monosulfide gas at STP, and I've given you the balanced chemical equation. Now while this may seem really complicated at first, as long as you remember in your dimensional analysis problem solving, as long as you remember to follow the units through and really think about what's going on with your units, these kinds of problems can actually be fairly simple. They can be long, but fairly simple. So I'm going to take what I'm given, 135 liters of oxygen gas. And then I have to think about what I want for my answer in units. It's asking for mass, so I know in the end, somewhere over here, I'm going to get a certain number of grams, and then it's asking for sulfur dioxide gas. So I'm switching both units and substances. Now, just as always, if you are not given a mole, always go to the mole first. You know what to do with calculations once you get to moles of substances. So I'm going to put liters of O2 on the bottom of my conversion factor so that they can then be canceled out, and convert that unit to moles of oxygen gas. If I stop here, my units are in moles of oxygen gas. Now I'm going to wait and go back and fill in the numbers when I'm all done setting up my units. You can do it either way. Now, what am I going to do with moles of oxygen gas? Anytime you're in moles of a substance, you can switch to moles of another substance using a mole ratio from your balanced chemical equation. So I can put moles of O2 in the bottom of this conversion factor, and I can go to moles of the substance that I'm converting to, sulfur dioxide. You see how I'm always keeping my end in sight. This is my goal for units. So I'm working with the units right now to get to the right units in the end. If I were to stop here, my answer would have units of moles of SO2. But I'm not quite done because I need units of grams of SO2. So can I convert from moles of SO2 to grams of SO2? Well, sure, that is the molar mass, so I can just calculate that from the periodic table. Once I have the units set up, I can go back and put the numbers in that correctly match the units. In this first conversion factor, and you consider each conversion factor individually. So if I just look at this, I'm converting from liters of oxygen gas to moles of oxygen gas. That would be the molar volume. 1 mole of oxygen gas has a volume of 22.4 liters at STP. Now, looking at the second conversion factor, I see I have moles top and bottom, but I've changed the substances. You convert from one substance to another using mole ratios from the balanced chemical equation. So the numbers that go in here are the coefficients for each of the element, or each of the substances that I have given here. So moles of SO2, that gets a 1. Moles of O2, that coefficient is a 3. Finally, a molar mass, so I'm going to calculate this. 1 sulfur has a mass of 32.07 grams per mole. 2 oxygens, 2 times 16.00. And that's the molar mass for sulfur dioxide. Then I'm just going to go through and do the math. Again, multiply everything on the top and divide by the product of everything on the bottom. So I'm going to punch in 135 times, I have to put in the ones, 64.07 divide by, be sure you include the parentheses, 22.4 times 3, parentheses, is equal to, I gotta think sig figs, looks like I'm going to have 3, way more than 3, infinite, so 3. 129 grams of sulfur dioxide.